My name is Aileen Wijaya
My name is Amanda Lam
from
JCB!
the best class ever,
Duh.
And
The best group, obviously.
so today, sir, bullying sir.
Okay.
So today, me and Mandy are going to introduce you guys to the periodic table, and we don't want to keep you waiting, so let's get started.
Here we are providing you guys with a diagram of the complete periodic table. A periodic table is basically the chemical elements arranged in order of atomic number, usually in rows, so the elements with similar atomic structure and hence similar chemical properties appear in vertical columns.
So you guys might be wondering, who created the periodic table? So the genius scientist who created the periodic table is Dmitri Mendeleev, and he created it to show all the elements known in the universe and to organize the elements by chemical property, so it's like easier.
Yeah. Well, an element are usually organized on the table according to their atomic number. This refers to how many protons an atom of that element have. No two elements have the same number of protons.
Moving on to atomic mass. What is atomic mass? It refers to the weight of the atom. We can find it by adding the number of the protons with the number of neutrons. Next, valence electrons. They are the electrons in the outermost shell of an element. They can be transferred or shared when atoms bond together. You can also tell the amount of valence electron an element has by looking at their group, which group they are in.
Aileen, tell me more about cations and anions. What are they?
So you guys know that each element have their own amount of electrons, right? They're valence electrons. And obviously most of them aren't stable because an element, in order to reach a stabilized state, they have to have 8 valence electrons, and only some elements have 8 valence electrons and 2 valence electrons. So to stabilize themselves, they usually receive or give away their valence electrons. As for elements that have 1 to 3 of valence electrons, they tend to give away their electrons to other elements that needs them.
Wait, Aileen, does that mean that groups, elements that have 5 to 7, they receive?
Yeah.
Oh,
That's correct.
okay.
So elements that give away their electrons are metals, and they are called cations. Yeah.
They have a positive charge, right?
Yep.
And for
Because-
anion, they have negative charge.
Because they give away their electrons, so the proton will be more in amount. Yeah.
Oh, thank you, Aileen.
Yeah.
Yeah.
What are groups?
Groups are arranged in a vertical order, so basically in a column where elements with similar chemical properties are arranged in.
I've also heard another term called periods. What are they?
Oh, periods are basically the exact opposite, where it is arranged from left to right for elements with the same number of electron shells.
So basically, you're telling me that groups are columns in the periodic table, where periods are like rows, right?
Yeah, exactly.
To simplify, yeah.
Well, a periodic table consists of 2 types of elements, which consists of metals and nonmetals. For the group 1, which are alkali metals, they consist of 1 valence electrons, which, if I could recall, it's basically the outermost electron number. And then for group 7, it basically has 7 valence electrons, and group 8 has 8 valence electrons.
And if I'm not mistaken, group 1 metals are called alkali metals, group 7 are called halogens, and group 8 are called noble gases.
You're right.
I'm smart, I know.
Aileen, what is this?
You don't know what this is?
No!
This is metal!
What? What are metals?
So metals are basically the elements on the left side of the periodic table, and they have a lot of properties. They are good conductors of heat and electricity. They're shiny and they're ductile. They can be stretched into thin wires like copper. And they're also malleable. They can be pounded into thin sheets. So a chemical property of a metal is like its reaction with water can result to corrosion, like the yellow thing you see in metals.
Aileen, what is this?
You don't know what this is?
No!
This is scratch your back.
What is it, though?
They're
No,
made of
wait, that's... Aileen, what is this?
You don't know what this is?
No!
This is scratch your back.
No, silly. I want to know what it's made of.
Oh, it's made of wood, a non-metal.
What are non-metals?
So like basically they're the elements in the right side of the periodic table, and they are sadly poor conductors of heat and electricity. They're not ductile or malleable like metals. Boo! And they're brittle and they break easily. Ugh. They're also dull, and many non-metals are gases, but this one is not an example of the gas. The air we breathe is a non-metal.
Like I said before, group 1 metals are actually called alkali metals. They usually consist of 1 valence electrons, which is the main reason why they are usually soft. Because, well, yeah, they only have 1 valence electron. And alkali metals are actually very, very reactive. How about the trends, Aileen? What are they?
So as you go down the group or the columns in the periodic table, alkali metals tend to be more reactive, like when you go down. And the density will also increase as you go down the group, but the melting points will decrease. Why? It's because of the shielding effect. As you go down the group, the shells, they will increase in size. And obviously, the attraction between the proton in the nucleus and the electrons in the outermost shell will decrease. So the valence electron in an alkali metal will be easily taken by another element.
You guys may be wondering, what are the elements between group 2 and group 3 called? Well, they are called transition metals. And some properties of it would be that they can act as a catalyst. A catalyst is something used to speed up a process. They usually have high densities, usually hard and tough, high melting points, but mercury at room temperature. They can be hammered and bent into shapes easily. They are really good conductors of heat and electricity, and they are actually colored compounds.
As for the trends, transition metals don't have a specific trend, so they're not like group 1 and group 7.
I would like to discuss about group 7 elements. They are actually called halogens and are gases, meaning that they are non-metals.
As for the trends in group 7, as you go down the group, the density increases and the reactivity decreases, unlike alkali metals. As for the boiling point, they increase. Why? I've said it before, the shielding effect, but it's different for halogens because halogens have 7 valence electrons, so they tend to take other elements' electron and take 1 electron. So the shielding effect between the nucleus, the protons, and the electrons in the outermost shell, because as you go down the group, I've said, the electron shells increase. So the attraction will be less, and it'll be harder for them to take in other electrons. So that's why their reactivity decreases. Oops, we forgot to mention. Group 7 elements are generally diatomic except for astatine. And another thing, what are displacement reactions?
Well, displacement reaction is when a more reactive element replaces a less reactive element. This process is called displacement reaction. For example, finally, we have reached the end of the periodic table, which is group 8. They are usually called noble gases, and they usually consist of 8 valence electrons. I don't know if you guys remember, but valence electrons are basically the electrons in the outermost shell. Except for helium, they only consist of 2 valence electrons. Noble gases tend to be happy because their outer electron shell is already filled and balanced. Noble gases are non-reactive, they are inert gases. So it concludes that they are non-metals. How about the trends, Aileen? What are they?
As for group 8, they have no trends because they're already stable. They have 8 outermost shell electrons. But for helium, they're special. They're called a duplet element since they only have 2 electrons in their outermost shell, but they are still stable.
Yay! We're finally done, Aileen.
So did you guys enjoy our video?
Tell better did.
Yeah. Don't forget to subscribe to BBS Pick Chemistry.
I don't think we're gonna even get posted.
It's okay. We love you, Sir Gopi.
Bye!
We love PBS.
Love BBS.
Pick.
Pick only.
Bye!